Okay, so in this lesson, we are going to determine whether a relation is a function or not a function. Not a function. Okay, so I want to introduce this idea of students and a school. So students can go to school. A student can go to one school at a time. Like if they go to Daggett Middle School, they do not go to Rosemont Middle School. They can't go to two different schools at the same time. So this one is good, right? And a student cannot go to one school and another school. So school A, school B. I think I can write this school a little better. They can't go to school A and then school B. This is bad. But student A and student B can both go to the same school. I'll put same. Like that's perfectly fine. So let's think about this. So I have a table of x's and y. So 0, 1, 2, 3. 0 remember these are students and these are schools. So student 0 can go to school 1. Student 1 can go to school 3. Student 2 can go to school 4. Student 3 can even go to school like 4 again. Because these two students can go to the same school. That's fine. But remember, these are the students, and these are the schools. Let's say we had student 0 go to school 1, student 1 go to school 3, student 2 go to school 4. Student 2 can't also go to school 5. Like, that's bad. So we are going to go ahead and dive into this. Example number 1. Remember, these are students and these are schools. So student 0, 1, 2, 3, 4 goes to school 2, 4, 6, 8, 10. Remember, these are students, these are schools. So each student goes to a different school. That's fine. So y is a function. Y is a function of x. And we skip this because it was a function. All right, so example number 2. This student goes to school 2, this student goes to school 3, this student goes to school 6. The same student, student number 2, goes to school 6 and 7. That's not possible. So, if not a function. So 2 cannot go to 6 and 7. Oh, I know what we're supposed to put here. So f of x is not a function of x. So f of x is not a function of x because 2 cannot go to school 6 and 7. Okay, example number 3. So 1 goes to 2 and 1 goes to 4. So let's remind ourselves. These are students, these are schools. Student 1 cannot go to school 2 and school 4. So z is not a function of W. Z is not a function of W. So it's not, so 1 cannot go to 2 and 4. And let's circle that. Okay? So kid 1, it makes it easier if I write it. Okay, so we have this kid. This kid doesn't repeat, so I don't have to worry about this kid or this kid. I just have to look at this kid right here. So this kid goes to -12 and -6 and -9. So I is not a function of P. So if it's not a function, that's because 2 cannot go to -12 and -6. Of course, I could put and -9, but you're good. Like, I wanted to make sure, like, try to make it so that you could fill this out. Okay. Example number 5. So students in school. So I don't have to check this student. I don't have to check 13 or 14. I only have to check this student right here. So this student goes to school 4, and this student goes to school 4. It's just repeated information. I guess it was a mistake maybe, but like, it's saying the same thing. This is fine. This is good. This is no problem. So Y is a function of X. If you notice that these kids go to the same school, and that's fine. That's absolutely fine. It's just that the same kid can't go to more than one school. So 21 is good because it doesn't repeat. This kid doesn't repeat. This kid doesn't repeat. It's always these 2s that seem to repeat. I don't know what happened when I made this. So this kid goes to school -2 and -3. So this is a problem. So L is not a function of T. Because 22 cannot go to -2 and -3. Cool, let's go to the next page. So sometimes we have these like diagrams here. I want you to think about these as just the tables, but in bubbles. And this is the schools. School. And just think about it as going like this direction. So this kid goes to one school, this kid goes to one school, this kid goes to one school, this kid goes to one school. Okay, cool. So this doesn't give anything, so I'm just going to label this X and f of X. So f of X is a function of X. Cool. Let's do that again. I want to put X, f of X. Okay, so this student goes to this school. This student, same student goes to this school. Oh, it's that 2 again. That's just coincidence, but we don't even have to check because 5, I mean, we could, but like 5 only goes to T, 6 only goes to T, 8 goes to R, 9 goes to S, but this person 2 goes to these 2 schools. So f of X is not a function of X. Then that's because 2 cannot go to R and S. Example, I guess 3 in this section. Once again, X, f of X. Ooh, I don't know. Actually, looking back, this f of X means that it is a function. It was fine here. So we probably shouldn't use f of X because we don't. F of X means function. So let's change this to Y for now because we won't know until we check it. Okay. So right here, we're going to change this to Y. So this kid goes to this school, this kid goes to the same school, this kid goes to this school, this kid goes to this school, and another kid goes to the same school. So looking good. So y is a function of x. Okay, one more. Let's do x and y. This kid goes to school 3 and 4. Oh, this kid's an issue right here. So y is not a function of x. Now, if you prefer, we could go back up here, and this one worked out, but if you prefer, you can just put y here. Okay.